A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, course instructor for the NPTEL MOOC course Pavement Construction and Technology funded by Ministry of Education, Government of India. Today's lecture will cover the field evaluation or the field test which are required to ensure the subgrade quality in the field, and this will be under the module 5 of the course. At the very beginning, I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. We have discussed in our previous lectures about subgrade, its role, its composition and how the different materials which needs to be used either for embankment construction or subgrade construction need to be ensured in terms of their quality. So, characterization of the subgrade materials or the materials required for the earthwork in terms of embankment and your subgrade. Here we will be discussing in this particular lecture some of the aspects which are required to ensure the quality of the subgrade during the construction in the field. We mentioned earlier that the soil subgrade forms the foundation layer. Mainly, this is mainly constructed with natural earth upon which all pavement layers are constructed. So, it is mainly constructed with the. It is essential that at no time subgrade shall be overstressed, because ultimately all pavement crust layers will come over this particular one. So, we want to ensure that at no times it is overstressed by which means pressure transmitted over the top of the subgrade should be within the allowable limit. So, during the pavement design also we take care that the compressive strains at the top of the subgrade are well within the permissible limits. With respect to the design traffic, it is always preferred that a minimum 50 mm thick of subgrade soil be thoroughly compacted. So, this compaction need to be ensured. How do we ensure that thoroughly compacted? So, that is a part of check during the construction. It should be thoroughly compacted under carefully controlled conditions. One of the condition is the moisture content at which it is to be compacted. If proper moisture content is used, then we can expect to achieve the desired density, especially at the optimum moisture content and maximum dry density. This is what we target to have to achieve a stable and durable foundation for the pavement subgrade or the pavement structure. Now, as mentioned earlier, that the top 500 mm of the prepared foundation layer located at the bottom of the pavement structure is designated as per our IRC 37 for the specifications for flexible pavement design. Now, if the field testing is to be done to ensure the subgrade quality or the embankment quality, or in general we can say the earthwork quality at during a road construction project, then under this particular one there will be a series of checks which are required, so that whatever the especially the subgrade is meeting the specified requirements. So, field testing and inspection of the constructed subgrade are vital components of any road construction project. These checks ensure that the subgrade meets the required specifications which are laid by different codal standards, MORT and IRC standards, providing a reliable and uniform foundation upon which the pavement crust is designed and constructed. Now, there are certain checks which needs to be ensured, followed to ensure the quality of the subgrade during after construction as per the MORTH guidelines, which says that you need to ensure for the control of the alignment, that is levels and slopes, what should be the level of your bottom of subgrade, then how many layers of subgrade you are putting up. Also, each layer, what should be the compacted thickness of each layer, what should be the cross profile of that particular layer. So, that needs to be ensured through the alignment which is available with you or through the drawings. Surface regularity of the layer also needs to be ensured. There should be not much undulations present, because finally we try to control it from the subgrade itself, so that when it reaches to the top we get a very smooth surface. Rectification of subgrade, if any, if we during that course of time, if we are able to figure it out, or we are able to locate certain sections which need some improvement, we will do it. We can do it during the construction also, we can do it after construction before laying the next layer. So, compacting control check, this is again compacting control check on the earthwork for embankment and subgrade construction, especially this is compaction control check. This is what we are requiring here is a compaction control check on the earthwork for embankment and subgrade construction. Now, this shows you will have drawings of whatever the project you are going to look after. So, in that particular one you will be able to get certain informations. Here in this one I just wanted to show that you have one as the FRL, which is your finished road level, and this is at the center line. So, it gives you levels of the center line of your road, and then there is an original ground level again at the center line. So, the original ground level may be different. You can see the red line is the finished road level. Once the road construction will be over, this will be the profile of the center line of the road, and earlier this green which is showing in this particular manner is the original ground level. And at places you can see through the difference between these the level of these two center lines, original and the finished one, we can say figure it out what is the difference. So, here we can see there is some filling which will be required. Here also a lot of filling will be required, here some amount of cutting will be required. At certain levels you will find it is approximately matching with the natural ground. So, you will find the differences are very less. So, this is another aspect. So, with this particular one and you can see there is a horizontal curve. So, you will figure it out what is the radius of the horizontal curves. Many other parameters can be extracted. So, this deals with the geometric design of your any project. Now, from this one, now you are able to know what is the finished road level of my center line. Now, with respect to the center line, there will be side slopes or there will be a super elevation is there. So, I will be able to know what are the levels at my edges of my pavement. So, and then I can figure it out based on my crust thickness. So, I can see this is an example here. This is a carriageway which is shown, a 7-meter carriageway is there, and with a camber of 2.5%. I am just trying to give you a glimpse of it. Then the composition, there is a bituminous concrete layer is there, dense bituminous macadam layer, wet mix macadam, then GSB is there, and at the bottom of it subgrade will be there. They have given a paved shoulder, and then cycle track is there, even footpath is there, all those. Now, you can see the ground level is also mentioned here. So, ground level with this particular one, a lot of embankment will come up, layers of embankment will come up, and then the construction of subgrade will start, so that you get a finished road level. So, when you are compacting each layer, you know the finish from your drawings, you know the finished road level, especially at the center line. With the use of these side slopes or the cross slopes, I can work it out what will be the levels at these locations. Then working out the my pavement crust thickness, I can work out the levels at these points. Then considering how much amount of fill is required, I already have these natural ground levels or original ground levels with me. So, I'll do the construction layer wise, and I'll fix up, okay, with this particular center line for the first layer of embankment, this will come up as the levels for the top of the first layer of embankment. Similarly, what will be the levels at the bottom of my subgrade. So, with this one I can figure it out what are the levels which needs to be achieved when I am doing the construction. So, a good surveyor team will help you to carry out this particular exercise. You can again see there is a composition. This is a detailed cross section which shows what is there. Here you can see this is the original ground level, and then you have this one as your subgrade. So, I'll come to know what is this subgrade bottom, and the subgrade bottom has to be constructed as per the cross slope. So, this is then for each layer I will work it out, then I will work out for the subgrade top, I will ensure it during the construction also. Then for the granular subbase course, because camber has to be maintained, otherwise where you are constructing the drainage layers, the water should flow through your drainage layers. So, this is possible when you are providing the adequate camber from your initial construction from the subgrade itself. Now, what are the codal guidelines which suggest when you are looking into this particular one? So, as I mentioned, this is a surveyor team. So, there as an in charge, you will look to the exercises where the surveyor team is doing the proper check over the individual layer preparation, and after compaction also what levels are coming up, what is the cross fall or camber we are able to maintain. So, all earthworks performed shall conform to the lines, grades, cross sections and dimensions shown on the drawing, because the width of these layers will be different. As I mentioned, when we construct in earlier lecture, when we construct drainage layers, they are to be exposed to the ends, so they are constructed for the entire width. So, that needs to be ensured. Now, what MORT says about it, when you are looking into the horizontal alignment, as I have shown in the previous slide, the horizontal alignment is to be determined with reference to the center line. As mentioned, there the center line levels are given of the carriageway as indicated into the approved, and you should verify it with your approved drawings. There are drawings which needs to be approved by respective agencies. So, the constructed edges, now when it comes to the, as I mentioned, edges of individual layers, edge of your subgrade, edge of your granular subbase course, edge of your base course, edge of your binder course, edge of your wearing course. So, all the edges, the ends of it has to be checked. So, it says the constructed edges of the carriageway shall conform to this alignment within a tolerance of plus minus 10 mm. Always it is important that otherwise the effective width gets reduced. If it gets reduced, you will not get good support. So, this tolerance of the edges are in the range of plus minus 10 mm, specifically the carriageway part we are mentioning. The corresponding tolerance for the edges of the roadway and lower layers of the pavement shall be plus minus 25. So, if you can see when you go up on the top, the tolerances will be very small compared to what tolerance you allow at the bottom layer. So, when you are doing the construction for your especially the lower layers, you give a tolerance of around plus minus 25 mm. So, 2.5 centimeter can be there. The constructed levels of the subgrade shall not deviate by more than 20 plus minus 20 mm. As I mentioned, if I calculate say the level with respect to the center line is the bottom of my subgrade with respect to the, if there is a finished level, if this is my finished level, finished road level center line, and it says that this if I keep this particular one, say I'll mention it 1.2 meter. This is with respect, because this is mean sea level, or you will have your benchmarks, temporary benchmarks, and this reduced level will come up. I am just mentioning that with respect to any benchmark, if I have fixed for a reference point, I am mentioning that this particular point, this is my center line levels will be given with respect to any benchmark. And so, it may be say, and that may be with respect to the mean sea level. So, it is with respect to the mean sea level, say 101.2 meter it is there. Now, when it comes down here, I can say this is, I have a crest of around say 1 meter. So, this will come up to be 100.2 meter. So, this will my subgrade top, and when it will come up a subgrade of a thickness of half a meter. So, this will come up in that case 99.7. So, this will be just at the bottom of my center line. The level of the subgrade bottom will be 99.57 if I am doing a construction for a half a meter of subgrade. Now, with respect to this one, there you will have a, with respect to this you will have this camber again. So, you will come to know what is this width which is to be constructed. So, you will know, so with the whatever say 2.5% camber, what will be the slope here and what will be the slope here. Then I will put up one layer. So, it may be a layer of say 25 centimeter and second layer of 25 centimeter. So, for each layer I will be able to. Now, it says when one layer is constructed with a camber and you are making a check over the with your surveyor team, either at the bottom or on the top of first layer or on the subgrade top, you need to ensure that the levels are not deviating by more than plus minus 20 mm, that is 2 centimeters. So, your layer if is of 20 centimeter, it can be either 18 centimeter or 22 centimeter. So, this needs to be ensured once. So, one layer is constructed, then you are going to look into this particular check. With respect to the longitudinal and cross sectional profiles required, because you need to know what will be the cross slope, and with that you can work out the slopes which will be there at the edges. And now, while doing this, so once you have a prepared layer, whether it is your first layer of subgrade, whether it is bottom of your subgrade, that also needs to be prepared, whether top of the subgrade, you need to ensure the surface levels. And for this, how many points can be taken? So, we can form a grid. So, it says it can be on a grid with points spaced as 6.25 meters longitudinally and 3.5 meters transversely. So, this is not shown as per the scale, but just for an example, from the edges I can work out these grid points, and then I can ensure the levels at these grid points and check whether they are in the tolerance of plus minus 20 mm with what I arrived from my standard drawings. And if I am able to see that there are certain deviations which are coming within plus minus 20 mm, but certain which are going out of it, then it says in any series of 10 consecutive measurements taken in either direction, no more than one measurement shall be allowed to exceed the specified tolerance of plus minus 20 mm, especially in the case this tolerance is there different for different layers. If I will go for sub base courses, base courses, binder courses, because I can't give a tolerance of 2 centimeter, plus minus 20 mm means plus minus 2 centimeter when I am constructing a bearing course of 5 centimeter. So, I can't make it 3 centimeter or I can't make it 7 centimeter. So, this tolerance will keep on reducing as you are going to go on the top of your pavement crust. So, it says that if you are making 10 consecutive readings are taken, and in that particular case no more than one measurement is allowed to exceed the specified tolerance, and that single deviation shall not exceed the tolerance by more than 5 mm. So, it should not go beyond 25 mm in the case of your subgrade. So, this needs to be ensured when the individual layers are getting constructed. In addition to this particular one, for surface irregularities, for small undulations that can occur, because that is very important, we need to have a very smooth surface on the top. And for this particular one, it says the longitudinal profile shall be checked by a 3 meter long straight edge. This is a straight edge and this is a wedge which can be inserted. So, if a surface is perfectly smooth or perfectly straight, there will be no undulations under it. So, this wedge when inserted will give you how much amount of undulations are. So, if the height of this particular, the gap is there of say 4 centimeter, whatever more than 4 centimeter and lesser than 4 centimeter will come up, will show some amount of undulations are there. So, here with this straight edge we are going to see for the surface regularity, and this will start again from the subgrade construction itself. So, we can use this longitudinal profile measurements by using do this one by using a 3 meter long straight edge. We call it as a moving straight edge as directed by engineer, especially this is engineer in charge is the one who finally looks for a construction. So, he takes many decisions on his own depending upon how much variability is there, some site specific challenges are there, regional challenges are there, material challenges are there, construction challenges are there. So, he takes the decision, sees the limitations and the variabilities there. So, preferably it is done at the middle of each traffic lane and it is done parallel to the center line of the road. So, we have, if this is the one, this is your center line which is can be there on the one, then if there are 3 lanes it can be done in the middle of each lane and it will go parallel to your center lines, just it will go in this particular one if this is the direction. And what it says, the maximum allowable difference between the road surface and the underside of a 3 meter straight gauge when placed parallel with or at right angles. Even right angles also you can check if I am checking. So, if this is my surface and it goes like this way, if my road goes like this way, then I am just showing this to understand that okay, I am going in this direction. So, I can check it along this one at the middle of the lane, and I can check it at perpendicular to the center line. So, it can be done in both the directions. And so, what it says that at right angles or parallel to the center line at points decided by the engineer specifically, and this can be done at say multiple points. He can say okay, if he feels that at this particular one the undulations are more, with experience we will very well come to know where the surface is getting constructed in a good manner. From visual inspection, with experience works out a lot of things. So, it says, and definitely, but it should not happen that you are doing only visual evaluations, you are not conducting the regular test. It has to be conducted, this has to be used, your levels have to be taken up. So, you have to carry out this exercise, but what points can be selected can be done, either you do a random sampling or you can specify and check out okay, here I am finding it out good enough, but here it appears some challenges. So, let us look for this one. And there with this particular straight edge, it says that the allowable difference between the road surface and the underside of an straight edge should not be more than 15 mm in case of subgrade. Because why finally when we reach on the top of the surface, specifically this is a requirement which is given by MORT in section 900, which says that the surfaces of carriageways, the top surfaces of the carriageways, the irregularities should be retained in this particular range. And how it is to be retained? It says a 4 mm irregularity, if it is there in a length of 300 meter, it should be not be more than 15. So, for national highways and expressways, if 4 mm irregularity is there, so if you want to achieve that much amount of smoothness, it needs to be controlled from the level of the subgrade itself. So, there we are making a control of 15 mm at the subgrade. Now, if it may happen that at certain locations the levels may be low, or at certain locations it may be higher than what is permitted. So, in that case we need to rectify it before we go for the construction of the next layer, if those deviations are beyond the permissible limits. So, where the surface regularity of the subgrade course falls outside the specified tolerance, the contractor shall be liable to rectify this one, because this becomes its responsibility, and this can be done in various manners. If where the surface of any subgrade layer is high, it shall be trimmed. You can use a grader, you can use a dozer, it can be trimmed and then suitably compacted. So, a particular depth which you are finding it is to be high enough needs to be trimmed and need to be recompacted. Where the same is low, then at that particular time, especially we will do a slight scarification of the, because it is a compacted one. So, we will do a slight scarification of the existing one, then we will put some fresh material, so that it becomes one monolithic layer, and then recompacting it to the required density. So, at every layer this check has to be done, and if any rectifications are required, it should be attempted immediately, and then only you should proceed for the construction of the next layer. Now, this is, so once this is one part of a check where we are checking the surface levels, we are checking the surface irregularities. Then comes the checks which are related to the material part. So, quality of fill material, especially what quality of material we are filling and how we are compacting it, that checks are also involved. So, shall be controlled through exercise of checks on the borrow material. As we mentioned in the earlier slides, there may not be sufficient amount of cutting or soil which is available with you. So, you may have to select a borrow area from where you will be nearby borrow area, and then you will be evaluating, judging whether that soil is suitable, and if found suitable you can use it for your construction. So, you have to regularly monitor that there is no the soil which is coming from the borrow area is meeting your requirements, is whatever as per the standard requirements which has been considered for the design of the pavement. It should not happen that the borrow area soil quality which has been considered for the design, during construction there is a significant difference which occurs. So, we need to have a continuous check over it. And finally, it should meet out the construction specifications which are laid. So, what common tests which are done is gradation requirements are checked, plasticity index checks are there. We have discussed these tests, Proctor test for determination of maximum dry density and the optimum moisture content is there, moisture content determination, strength in terms of the California bearing ratio and free swelling test. And there are various specified guidelines which are there to have an understanding over what kind of quality control checks are required. So, this is one manual for quality control in road and bridge works, SP 112. Then we have recommended practice for construction of earth embankments and subgrade for road works, IRC 36 is there. Earlier this was there IRC SP 11 which is now amalgamated with IRC SP 112. So, and then we have these individual IS coded guidelines 2720 parts which are there, like this is for the grain size distribution, this part 5 is for determination of liquid limit and plastic limit, part 8 is for the determination of the moisture content and dry density, part IS 2720 for part 16 for the determination of the CBR of this. Now, here there are the requirement will come up, how many tests I need to do. So, and in what, if it should be in terms of the area, it should in terms of the quantity of the soil, volume of the soil which is going to be used. So, how many number of tests are to be done in a given volume of a soil, and so the frequency is important, and how many number of tests and how many number of times it has to be done. So, the type and frequency of test on borrow material depends on factors as the equipment used, because extent of manual labor, applicable specifications and site conditions, you can know that there is a lot of variability which is found in your the section which is getting constructed. So, there if you find that variability is more, the frequency of the test can be more than what is specified by the or what are stated in the specifications. So, as I mentioned, there can be gradation checks, and one statement important, the minimum requirement can be increased as needed based on material variability and compaction methods used. So, if I am using good compaction methods, and then I can look for the go for the standard methods of the checks for compaction, but if I am finding that the compaction methods which are used are not having a good control, specifically the rollers are not having a good control in terms of their vibrations. So, in that case I may require to increase the frequency of the test. So, gradation test, one test which is done, and it says especially for each kind of soil if there is a variability experienced, and it says normally you go for at least 2 tests per 3000 cubic meter of soil. So, and then you will check for the gradation and you will cross verify it whatever the limits is specified in your project requirement. One is codal specifications requirement and second is project requirements, because on the basis of that your entire project has been designed. So, there are standard codal requirements and specific project requirements also that needs to be ensured from the in terms of the gradation. So, the test is quite necessary if specifications calls for checks using gradations. So, there may be some specific requirements which may be specifically mentioned in your project document or your, so there you need to refer what specific requirements are there in terms of gradation. Like for example, sand content determinations are also conducted at the rate of 2 tests per 3000 cubic meter of soil. So, even these are certain tests which may not be general tests are most of the times mentioned, you go as per the MRTS specifications. Otherwise, if there are some specific requirements in addition to that particular one, they will put some more specific test. like plasticity index test. Normally one test for each kind of preferably soil is conducted, and then we go for 2 tests per 3000 cubic meter of soil. So, when because we can work out what is the amount of work which has been done in one particular day, how much length of the road is constructed, what is the width which is constructed, what is the layer which is constructed. So, I can work out the volume of the soil. So, if a construction of 2000 cubic meter has been done in one day, I will work out at least 2 tests over that particular one. So, Proctor test, now this is again to determine, to ensure whether the soil which I am using is meeting my requirements of density. So, I will do the Proctor test. This is to ensure that the soil is of requisite qualities coming out from boro areas, because it may happen that there may be certain changes happening in the quality of the soil in the boro areas. And it gives us further information about the optimum moisture content. So, continuously when these tests are regularly done, you are continuously getting update from your laboratory. So, you will have a well developed laboratory setup at the construction site itself. These samples will be sent there. You will continuously keep on getting information, and from that information you will come to know, okay, uniform soil is getting used. If you found, okay, certain changes are there in the quality of the soil, whether that is within the permissible limits or not. If not, then you have to look into measures, what rectification measures can be taken up, or that boro area has to be rejected and some other has to be selected. So, it says like for Proctor's test is specifically for density and moisture content determination. Again, it says 2 tests per 3000 cubic meter of soil. Deleterious substances which may be there, because we prefer that the soil should be free from salts like sodium sulfate and organic matter. Limits have been given. So, this test is to be done, and as more organic matter may be there in certain locations, so more frequency may be suggested by the engineer in charge for the measurement of deleterious content. Moisture content, as I said, moisture content is important for compaction also. Even during the compaction, because we prepared trial stretches, we worked out, okay, this much moisture content, if this is the moisture content, this much compactive effort will give you the required density. So, you need to, during the construction itself, not only after once layer has been constructed or one course has been constructed, during the course of construction also, you can keep on making these checks. Whosoever is there as a part of, whether it is the engineer from the contractor side or from the consultant side, he will look into to ensure these things. So, the natural moisture content, one is the natural moisture content. If that is not coming to your optimum moisture content, then you need to add water. If it is more, you need to aerate that particular one. So, the natural moisture content of the soil coming out from the boro pits is to determine in order to evaluate how far the natural moisture content tallies with the optimum value, that is optimum moisture content, and whether further addition or reduction of water content would be necessary, whether we need to aerate it or we need to sprinkle more water to reach to the requirement of optimum moisture content. And for this particular one, normally we go for at least one test 250 cubic meter of soil. And then in addition to this particular one, the important in respect of strength, that is the CBR. So, we will measure simultaneously the CBR of this particular soil which is getting used for your subgrade or embankment construction. So, CBR test on materials to be incorporated in the subgrade under soaked and unsoaked conditions. So, this will be mentioned in your project document, whether it has to be conducted under soaked condition or unsoaked conditions. So, and it says the rate of testing is mainly one CBR test per 3000 cubic meter of soil. This is an average and or closer. So, this can be when required. Even he can feel, okay, no, I need to do 2 tests, I need to do one test every 2000 cubic meter of soil, because a lot of variability